Now we look at the equation log of 3x minus log of x to the fifth equals 9. In order to solve this, we first combine our logs. Remember, the log of the difference of two things is the log of the quotient. The difference of two logs is the log of the quotients of the two quantities. Log of 3x over x to the fifth then equals 9. And we simplify the 3x over x to the fifth down to 3 over x to the fourth. And then we take the inverse function. We apply the inverse function of the log to both sides, which is the 10 to the x function. So we take 10 to the log 3 over x to the fourth equals 10 to the ninth. Proceeding, the log of 10 times the log of something is just a something, so we get 3 over x to the fourth equals 10 to the ninth. 10 to the ninth is just a number. We're going to leave it like this. Multiply both sides by the common denominator, x to the fourth, and then we're going to divide both sides by the 10 to the ninth. We get x to the fourth is 3 over 10 to the ninth, and etc. The etc. is real simple. Move the decimal over 9 places, divide it out using your calculator, whatever works for you. Somewhat more complicated equation. We've got numbers out in front of the logs and a plus here, and then more complicated expressions inside the log, but this still isn't all that bad. The first thing we want to do is get these numbers inside, so we have the log of something plus the log of something, and we can combine the two somethings into one log. So using the laws of logarithms, 4 times the log of something is the log of that something to the fourth, and 2 times the log of a quantity is the log of that quantity squared. Now we can add the two logs. We get the log of 2x plus 1 to the fourth times x minus 3 squared, okay, because of another law of logarithms. And then we exponentiate both sides. Apply the 10 to the x, the inverse function, to both sides. We get 2x plus 1 to the fourth times x minus 3 squared equals 10 to the seventh. Doesn't look too bad until we realize we can't solve it. So what do? Well, we notice these are both even powers. We could take the square root of this side, the square root of both sides, and we could reduce these powers a little bit. Okay, so we do so. And we end up with 2x plus 1 squared times x minus 3, taking the square root of the fourth and the second power, we get the second and the first power. And the 1/2 power 10 to the seventh is 10 to the 3.5, laws of exponents. So we get this. Now if this was a quadratic equation, we'd be in good shape. We'd be home free. But this isn't a quadratic, it's a cubic. If we multiply these out, we get an x cubed plus something plus something. There is a way to solve these, but my basic comment here is good luck. But then we scratch out good luck and say, use derive. Okay? We don't use that formula for solving cubic equations very often because it's complicated, hard to remember, and doesn't make a whole lot of intuitive sense.